Thanks.
We got to pull up the screen here.
That's great. Let me make a quick intro, Bill. Again, I just touched on our sponsors. Thank you. You've made this webinar series possible. Really excited about this. So thank you everyone for attending Griffin's Cannabis online workshop. This is a 5-part series that connects with improving efficiency and profitability in cannabis cultivation. Our goal for today's webinar and the entire series is that you learn about innovations that you can implement immediately or in the near term that can move the needle for you and your team. Today's presentation is by J.R. Peters Sales Manager, Bill McAvoy, and their Director of Technical Support, Caitlin Sterner. They'll be taking us through the steps of setting up an efficient nutrient monitoring program. Feel free to enter questions into the chat, and let's have a great webinar. Bill and Caitlin, it's all yours.
Thank you, Greg. I'm not seeing the screen here, though, as far as our presentation. Is that coming up?
That should be, yeah.
Yep. Okay, Caitlin. All right. Thank you. Thanks for that introduction, Greg. We're happy to be here. My name is Bill McAvoy. I'm the sales manager for J.R. Peters Jack's Fertilizer. And with me today is Caitlin Sterner, our Director of Technical Support. We did want to have our technical support specialist, Brett, with us today. Unfortunately, he had a little bit of a family issue that he had to take care of. So we'll get rolling right with it here. Our products are made in the USA. They're made in Allentown, Pennsylvania. For those of you who might be spread out across the United States, Allentown is about 60 miles north of Philadelphia, home of the Philadelphia Phillies, good baseball team this year. And we've been there in the Allentown area producing fertilizers in the lab for over 76 years now. So a lot of history there. We make products for the CEA, cannabis, ornamental horticulture, and we also have our Jack's retail line, which is called Jack's Classic. All of these products are high quality at low cost. Typically, they run about 2 to 5 cents per gallon out the end of the hose or the emitter. Some of the high phosphorus fertilizer products may be a little higher than that, but fertilizer costs are starting to come down. So again, generally, typically the costs are 2 to 5 cents. Our products are very efficient and effective. We ship you the powdered formulation. We do not ship you fertilizers that are mixed up with water. We don't ship water. All our fertilizers are made from technical grade or what we call greenhouse grade ingredients, and they're optimized to meet your specific needs. And in this case, it's going to be cannabis. And so we look at these formulations and we design the micronutrient package with cannabis in mind. Our lab facility is on site. It's also where our administration office and our production facility is. The lab is very instrumental in our QC, quality control of raw materials that we use in the manufacturing process. So the lab does the QC for the manufacturing, but also does the solution, media, tissue, and physical nutrient analysis for growers. Caitlin, thank you. Okay, next we have a little bit here on the J.R. Peters family. Just what you want to see in a presentation, family photos, right? I promise there's only one. Okay. Let's go down to the right-hand side here to the fellow with the lab jacket on and the tie. That is our founder here, Bob Peters. And Bob Peters started the company about 76 years ago. And what Bob was a horticulture chemist. And basically what a horticulture chemist does is he looks at chemicals and fertilizers, what we now call nutrients, and how they interact with the plants and substrates. A horticulture chemist would look at optimum levels and what are the toxicity levels of these different nutrients. Also, he would look at how it would impact the environment. and how it might also work as far as the impact on the environment and animals and people. So Bob, that's how he got started. And initially, Bob went out and started to take samples for the cut flower industry. He had a red Jeep. He would drive around on US 1, Route 1, where all the cut flowers were located in New Jersey and Pennsylvania. And he would take samples, analyze those, and get back with the growers and tell them what they needed to do as far as to raise or lower pH, or what nutrients they needed to add, or corrections or toxicity levels they needed to be concerned about. So that's how really the company got started. We got started as a lab first. Over the years, growers started to ask Bob, well, Bob, why can't you bring some of these chemicals that you're telling us to use and bring them with you? Then Bob started to design and formulate some of the fertilizers, and then got into the actual manufacturing of fertilizers. Uh, the gentleman in the middle here is Jack Peters. And over the years, what started to happen was we got into the manufacturing of fertilizer products, and then Bob's son Jack here was very instrumental in designing some of the Cal Mag products that are available out there today. Bob and Jack actually held a patent on some fertilizers, which were Cal and Mag products, where they were blended together. And so the family tradition continued. Now, as we go up to the third photograph at the top here, this has almost come full circle. The lady on the left here is Dr. Carrie Peters Raymond, and that's her husband, John Raymond. And together they are running the company. But Carrie has made a very significant impact on the lab as far as upgrading the lab, getting new equipment into the lab. So she's really following in the footsteps here of her grandfather, and this has all kind of gone full circle now. So very interesting story. That's all for family photos for now. I did want to point out, though, however, in the background of all three of these photos, those are silos. And if you look down on the right again at Bob Peters, there's a rail car there. We still get a lot of our raw materials delivered by rail. You see all the tubing and piping there. We actually draw the fertilizer raw materials out of the rail car, and then they're blown up into the silos, and that's how the products are stored. So just a little insight there in the background of the photos. Thank you. Hey, since 1947, when Bob Peters started this, we've analyzed over 1.5 million laboratory samples. As a matter of fact, this past year, the lab has just exploded. I think we've beaten, 3 months in a row now, Caitlin? They've surpassed the record number of samples that they've received in there. So again, we do samples for ornamental horticulture, CEA, cannabis. When I say we've seen it all, I really mean that. Over the 76 years of doing this and working in the lab, we have seen a lot of things come in, a lot of tissue samples, a lot of soil, and a lot of water. And again, that really helps us understand plant nutrition. Getting back to Dr. Carrie Peters Raymond, she has done a great job in getting the latest technology into our lab. We have hired lab technicians. This lab is up and ready to go and ready to meet the expectations of today's growers. So with that, I'm going to turn this over to Caitlin now, because she's going to bring you up to date on some of the changes we've made in the lab and where we're heading. Thank you, Caitlin.
Yeah, thank you, Bill.
Yep.
So here is a kind of before and after photo. So investing in science has been a priority for Carrie and J.R. Peters and Jack's Fertilizers as a whole, because at the end of the day, our lab is located in the center of our facility. It's truly the heart of what we do, because unless it goes through the lab first in terms of our raw materials, we're not blending fertilizer unless the lab gives the okay. And then again, till it leaves the door, the lab is running our blends and giving that the okay before it gets out to our growers. So really the lab is important. And these photos here show the before picture here. That was in late 2021, early 2022. This was the old lab. We pretty much were walking into a time machine every day. very 70s green, quartile. Just in general, we were working in a tight space, and we were able to allocate more space to work more efficiently and have the flow a little more comprehensive in terms of how the samples run through the facility. So the after picture here is our updated workspace with beautiful countertops, fresh flooring, up-to-date cabinetry that closes when you want it to close and opens when you want it to open. And just in general, we realigned some instruments. And these are just more of the back lab space. So we have a designated login area now, which is really nice. So all your samples that you send in, you can see on the cart here. We unbox them, we log them, then we organize them for testing here. This is the back lab space. Myself, on the technical team, I spend a lot of time here looking at different materials, evaluating blends. This is kind of my playground when questions come up and we have to check retains and so on and so forth. But this space got really nice for us as well. We were able to consolidate all of our large instruments, such as Scalar and our ICP equipment, into one space, which is really efficient and allows us to move samples more quickly. Right now, we're working on, at least for solutions, we're working on a 1 to 2 day turnaround time, which is pretty awesome. And then with tissue and media, you're looking anywhere from 2 to 3, maybe 4 days, depending how you hit it in terms of how close to a weekend you are for that kind of delay. But yeah, overall, it's just great steps towards more efficient science that allows us to work with you guys as well as growers to get you the data you need and help you grow better. And then this is our current lab crew. So if you do communicate with any of us, Sean, from left to right, it's Sean, Ryan, Nicole, and Steve, and they're doing an awesome job. Really great to work with, very closely with myself and our tech team. Just great people. They love plants too. And at the end of the day, they just want to get the results out as quickly as they can. So that's definitely a priority across the board when you're sending in samples.
Caitlin.
Yes.
How detailed is the login process, and for not only for you but also for what customers would be sending in?
Yeah, that's a really good question. So that kind of goes into the slide here, Greg. It starts with the submission form, really, and we just updated this, I'm gonna say like in August of this year. So it's only been out a couple of weeks at this point. Before we had multiple 3 different submission forms for the different samples that we had. And at the end of the day, we're like, oh, it was a lot of paperwork. We just wanted to streamline it, and we figured out how to do it, and we made this form. So really filling out the details, this is what we really need to know at this point when it comes to logging the sample. So when we receive the sample, we unbox it and organize them by delivery, by customer. And this submission form should accompany all samples. So as you can see here, we start in the upper left with the customer information. This is pretty much just helping us assign the samples to who they belong to. If you are a new lab customer or haven't used our lab in the past, an account number will be assigned once we receive your first sample. And you can signify that by marking off this new customer box that we added, which is super helpful. We also put a little more detailed for invoicing information, just because we want our billing to be as clean as possible. And the more details we have for that, the better on our side and the grower side. And then one of the best things that we have, especially from a tech standpoint, depending on who we're working with at different locations, you're able to add multiple people to your account to receive the samples. So if you have a head grower, an assistant grower, and a technical person on your team, everybody could get lab results. You just have to let us know, and we'll make sure that they're assigned to your lab count, which is pretty handy. And then what really streamlines it, and this is kind of the big thing, is that we, like I said before, we composed it all onto one form. So at this point, you can put media, tissue, and solution samples all in this column, and then just differentiate them with the descriptions, or use the back of the page as well. The back of the page is blank, so if you have more than 6 samples, you can make notes on the back of the page. That's not a problem. With any comments, If it's a solution, if it's a stock concentrate or whatever note you would want in there, either to the lab crew or for me or Brett or any of our tech people. The more you tell us, the better. So then we don't have to reach out for questions.
Yeah, our lab people like notes. I know they like getting them, so, yeah.
Yeah, and how it works then, so once we receive the sample and we log it into our system, into eLink or lab links, pretty much as soon as the sample number is assigned, an email is sent to the customer right away to let them know that the sample is received. So we always recommend to track the sample when it comes to us, but really at the end of the day, you're not going to get the official okay until you get an email directly from us saying we received it in our hands and it's in the system. Then you know it's here versus FedEx tracking. For the most part, everything is logged the same day it's delivered, unless for some reason we would have a late delivery. Sometimes USPS comes a little late, but for the most part, FedEx and UPS come earlier in the day. We'll get it processed by end of the day and then move forward with the next steps the following. So yeah, this is kind of fun. I was glad when this new form went out because it's just a good thing. We get a lot more out of it than we have before. So, all right, so let's talk about sampling. What's the difference? What's the difference with testing that you can do in-house or in terms of sending it to a laboratory? So we like to start by talking about in-house testing because at the end of the day, you can do more with it right away. So a pour-through test is what we lean towards a lot in terms of insight. A lot of our conversations that I have with growers starts with, well, do you know your pH and your EC of your container? What is actually happening in the root zone of your plant so I can get a better thought path in place in terms of troubleshooting. And that's pretty straightforward. I mean, all growers should have some kind of handheld meter in their fertilizer toolbox, grower toolbox, anywhere from a Blue Lab meter, a HANA instrument, something that can read pH and EC is going to help you make adjustments the same day, which is good. Saves time and you can make a quick adjustment versus, laboratory testing. That's going to be more in-depth. That's when you're going to be taking sampling. That's when you're going to be removing tissue. That's when you're going to be sending in solution. You want to see what's in that root zone and get a better understanding on specific elements, such as your macros, your micros, just the full picture of what's going on versus, just making slight adjustments with EC and pH in terms of frequency of your solution applications and so on. So it's kind of a general overview of the difference. And like I said, what you can do, and we can't stress this enough, myself and Brett too. Brett's like, make sure you drive this one home, is the first step every day, especially when you have big solution tanks and runoff, make sure you're keeping a check on your pH and EC. And I know software has come a long way. So a lot of software is able to monitor that and give you, the insight like right on your phone, depending on your setup. But still, having that handheld meter, you never know. There's still room for error with any technology. And that's where sending samples can give you that insight as well. The two photos here, well, obviously this is our handheld meter that we use quick in our laboratory, but we have better instruments. This is just what Brett and I use quick when we just have to check things. But here's a great example of where understanding your pH makes sense. So this is where we were seeing an iron deficiency, which once we received samples, the tissue was low in iron, but the media had plenty of iron there. It's just that the pH of the media was too high. The pH of this media was up close to 6, 8, 7. So we just talked with the grower and said, hey, we want to incorporate a little bit of acid here. When your pH gets up that high, your micros aren't quite available like they should be. We want to shoot 5.8, 5.5, something, mid fives. And a simple adjustment of incorporating some acid. And luckily in a couple of days, this was able to be turned around because the iron was there. So you don't always just want to be like, oh, iron deficiency, it needs more iron. You have to understand the element a little bit. So that's a great shot of what's happening there. I mean, my my experience in ornamental horticulture, this is like staple Petunia calibricoa problems. But when I had this come through with cannabis, I'm like, yes, this picture is gold right here. So I'm glad I could use it. And then this bottom photo here, you can see like the plant, it's getting like yellow edges. You know, it is trained a little differently, not exactly traditional. I think this was a larger home grower that was playing with some stuff. But at the end of the day, the plant was just pale. It wasn't like that nice green, uniformly pale. And when he checked the EC, it was showing that it was low. I mean, he only had an EC of 0.9. So we adjusted increasing his feed rate and feeding more frequently just to give them the plants some good boosts of nutrients and get things turned around. So, but that's all situations that can kind of be guided with basic pH and EC checks in-house. Do we have any questions we wanted to touch base on, Greg, or should we keep going?
A chat did come through for what is the cost of testing through J.R. Peters?
That's a great question. So across the board for sampling, they are $46 per sample right now. That's for solution, tissue, water, or media. $46 is the cost. It's fairly reasonable for a very quick turnaround time. This is what we always pride ourselves in. It's a quick turnaround time. You have myself and our technical team here. Like we want to be fluid. We're not just looking to push out samples. Like if you have questions or need help with interpretation, just give us a call. It's included with it. We want to help our lab customers and Jack's growers alike. So,
Caitlin, a follow-up to that is asking how many samples per crop. I know you have a slide on that, and we'll probably get into more detail when you're there.
Yeah, let's I'm going to go into that in a little bit more detail in a couple slides. So I'll dive into that in a minute. So, all right, so this is another great slide with some good visuals, and really it's just understanding when the right time is to send samples to the laboratory. You know, you're working with your plants, you're looking at your plants every day. Like, you know when they look good and you know when they look off. So I'll just go around here and give a little insight to each photo. The photo on the left here, this is a pretty severe calcium deficiency, which we really don't see it get to this point too often. I would say at this point, you're a little late in sending samples. This is where you might want to send them earlier, but regardless, we took them at the lab, we ran them, and it came up that the plants were very deficient in calcium. So right when things start to get weird, it's just not good. That's when you want to be proactive, be very aware. Even if you'd want to send us photos, I mean, I'm not crazy about getting photos because at the end of the day, I don't know exactly what it is without data to be confident in that. But if you're not sure, you could always reach out to Brett or I and be like, hey guys, what do you think? And we have no problem giving you some insight on our end with the experience we've had. So this photo down here, this is classic nitrogen deficiency, also confirmed with lab results, you know, just being underfed. Older leaves are yellowing, new growth looks great. They send in a good sampling. This was an outdoor hemp crop we were working with, and it was nitrogen deficiency. So this buffered versus unbuffered cocoa, this is kind of the classic of, you know what your plants should be looking like. Some of them are a little strange, and it was just not great cocoa. There was a lot of sodium and chloride in it, and the plants were a little stressed, and you can see it compared to each side there. And that's where, even if, you would get in media, and Bill and I were talking about this earlier today, whatever you're growing in, cocoa, rock wool, any kind of soilless media, our lab is able to test. We've tested compost. It doesn't always run great on our equipment just because it can be a little extreme and really push our limits of our instruments. But for the most part, soilless media is what we want to be focusing on. So if for some reason you would be trying new media, or you have a good relationship with a supplier, and we all know how ingredients have changed, sourcing ingredients have changed for various things, fertilizer, media, whatever. if you get fresh media and you just want to be sure, send us a sample. We'll run it. It's no problem. It's better to take, you know, a little bit of time in the beginning of the grow, so you can get to your harvest a little more confidently than have being like 3 or 4 weeks into a crop and you just have this uniform craziness across the board and it comes from your media. And we're going to dive into media analysis in a couple of slides here, but this was a good example of where lab results make sense. And then this is another photo, and I was telling Bill this, I'm like, I feel like I see pictures of this commonly, you know, just like this interveinal yellowing, crisp, kind of crispiest, just not green. And this was actually a manganese toxicity. So that again is a micronutrient situation. Iron and manganese have a correlation. Your pH is going to affect how it's available. So a lot of different ways you could get to the conclusion, but again, your lab analysis is going to give you the insight to what the next steps are going to be there. So, okay. So let's talk about tissue samples. So the main point to this slide is just being efficient with the sample itself. So, you know, can you send too much tissue? And we work with some facilities who, when they send a tissue sample, we're getting a big box of tissue with like 8 different strains in it. And all the tissue looks really nice and green. Now, don't get me wrong, maybe some of it's being used for research of some kind, but at the end of the day, we want facilities to be efficient with their lab testing as well. So if your plants are looking pretty good, like, do we really need a sample from every strain? It's up to you as the grower, but it's just something to think about in terms of your spending as well, being efficient, and how are you really using the data that you're going to get? Just things to think about. Every grow is different, but what you want to do, the photos here on the left, this is a fistful of tissue, and that's what we need for a sample size. So it doesn't look that big because they are laid like really nice on top of each other. But what you want to do is you want to take the most recently matured leaves on a mix of plants. You don't want to take your whole sample from one plant. You want to choose 5 or 6 different plants that are placed throughout your benches in different locations. Take one on the edge, take one in the middle, take one down the aisle, mix up your sampling just so you get a good representation of the crop across the board. And don't send us a whole grocery bag full. So this picture here at the bottom was, we got like a full grocery size bag full of tissue. And at the end of the day, like we still took what we needed from it. But we can only use so much, like we only need so many grams of dried tissue. So we don't want you defoliating your plants when you're taking samples, and just being smart with that. So there's good, and like I said, there's good versus bad. Bill, I don't exactly remember what we were trying to get at when we put this note here.
Well, I think what we're trying to look at is take a look at what looks good, what you're doing right, and what you're doing wrong. I think here is that's what you're trying to find, trying to correlate, just like we'll talk about with tissue and media. You want to look at your good results, you know, where am I doing things right, and where are things maybe going bad? And I think that's what really helps is if you look at the two, not just all good or all bad. I think you really need to look at what's looking good and what's looking bad.
Yeah, no, you're right. I remember now. So I guess that was what we were trying to get at. So say you have like a strain in a room and some of your leaves aren't looking great, but other plants' leaves are looking good. That's where you would want to take this 2 samples of a room. Take a sample of your healthy leaves, so you have a good baseline of like, okay, these leaves are like these plants, these leaves are looking good. I'm happy with this. This is what I think I want to be targeting, versus maybe some of the not so great looking plants. Taking a sample separately of that as like, these plants look a little off. I want to see what's different compared to these, and then have that kind of in-house comparison. So, and I'll dive into it more. We're going to get into the tissue ranges a little bit, specifically for cannabis, because even strain to strain, we have ranges, but who knows, strain to strain could be different. So that's where like a good sample versus a bad sample, if you have enough material to send in, can be insightful specifically to your grow, if that makes sense. So, and again, The full picture of plant health includes tissue and media sample. And now we're going to dive into that correlation so you can see what's really going on.
Before you move on, Caitlin and Bill,
Yeah.
what's considered a recently matured leaf? We had a question come in through the chat. They're asking if maybe is that 3 or so nodes down?
Yeah.
Yeah.
Just your
Yeah.
definition.
Yeah, that's pretty much it. You don't want your old leaves at the bottom of the plant, and you don't want your new growth on the top. You want like the top third of the plant, right before the new growth. That's going to be your most recently matured leaf. That's where your nutrients are going to be most true, I guess, to how the plant is really taking up that solution and using it, versus like your older leaves who are a little more mature. The nutrient makeup, it's not going to be too far off, but really like the most recently matured, that's going to be like the most accurate space on the plant of where all the elements are going to be equally represented, if that makes sense.
It does. Thanks.
Yeah. Any other questions right now?
Right now, the chat's clear.
Okay. Sweet. All right, so let's talk about when to send samples to the laboratory, which we've been doing, but we'll talk about this correlation to get the full picture. So when you take a tissue sample, that's going to be the analysis off of a tissue sample is a snapshot of what the plant is doing leading up to when that sample was taken. So you're going to be looking at the past 5 to 7 days of what the plant is doing in terms of using nutrients that you make available to it. While the media sample is going to show a full picture of the root zone the moment the sample was taken. So it's going to show what nutrients are available in that root zone as soon as you take the media, put it in a bag and send it to us. That's like a live shot. So when we look at them together, we can see what the plant is taking up from what's being available in the root zone. The key is, especially with media, when you're taking that sample, you do not want to do a clear water application before you take the sample, because all you're going to do is wash all the nutrients away and we'll get a good pH reading. And that's about all that sample is going to be worth, because everything's going to be depleted. So that's kind of the key. And then this chart at the top is our plant tissue ranges. So this is kind of just background on where we got our targets from, our ranges. So we had some references back before a lot of data was even really collected on this. Carrie, had some good resources she referenced. And then as we were able to fill our data arsenal with hemp leaf analysis, we were able to kind of hone in on these ranges and evaluate a lot of data and then correlate them for the specific elements to get a better idea of the targets we wanted our growers to be hitting, specifically our lab customers that were growing with Jax. This is where we want them to be targeting if they're feeding our formulas. It's this correlation, like our nutrients are delivering what the plant needs to grow optimally and efficiently and be within these ranges. So it's just a good chart there. But again, this photo here is that good amount of tissue to send, a fistful. What else? We say like a fistful or like 2 cups of fresh media is, or
I'd
fresh
say a
tissue.
cup and a half, 2
ideal.
cups, Caitlin.
Yeah.
About right. Yep.
Yeah. And then this is just a picture from the lab. We were prepping media that day. So yeah, fun stuff. All right, so you're at the point where you got our submission form, you collected your tissue, you put it in a box and sent it to us via FedEx or UPS is what we preferred. And you have your tracking information. You see it got to us, you got the notification that the sample was received. Then the next update you're going to get from us is the results. So what are the results? What are we looking at here? So let's dive into that. I'm going to go over a tissue analysis and a media analysis. So you're going to get your Results in two different formats. You're going to have a CSV Excel file, which is up here. And then all that same data is also reported in a PDF, which is much prettier to look at. And that's what these results look like. And if you're already a lab customer of ours, I mean, you know what this is, you've seen them before. But this is pretty much the standard of what our results are looking like. In the past, we had bars on them that signified low, medium, and high ranges based on the numbers that we're reporting in correlation to the ranges we had in place. But at the end of the day, those bars just cause more confusion and more questions for our customers. And even for our tech team, it just made, well, me personally, like I would look at things and be second guessing, and, you know, we just wanted it to be straightforward data. So we removed those bars, and this is what we have. Now the normal range here on the left side, this is not crop specific for any tissue that is sent to us. This is a very general range for plant growth. This is a range we got out of all the data we've received over the years, from ornamentals to vegetables to cannabis and hemp. Just general growth ranges you would want any crop to be within is where that is. Now, one benefit of being on this call is we're going to share the cannabis tissue ranges here for you. So this is important. You know, we'll share this when it's requested by growers too. So it's not something that's like super locked down. Everything we're sharing on here is transparent. But this is where things get a little more specific. When you do have a specific crop you're growing, and a lot of it, no problem for us to dive in and really look at the tissue ranges we're trying to target compared to the results on your analysis here. Not really quite sure how far we want to go into this. This is the Lemon Royale strain we had a sample from. Overall, everything was looking pretty good. I mean, I chose this as one of the more optimum tissue results we've received, and nothing in here is too glaring. Just this is what it looks like, was just using it as an example and then sharing these specific ranges. And a lot of times with cannabis, what we really focus on is right here, calcium and magnesium in tissue. We want to make sure that's proportionate to each other in that 2-to-1 ratio, which we're going to dive into a little later. And two, you know, your NPK, your macros, making sure that the solution you're delivering, the plant is using it and it's within that tissue and functioning as you hope. And then here is an example of media analysis. So again, you send in your media sample, you're going to get a CSV file, all the data in an Excel sheet, and then a PDF version as well. This I wanted to talk a little bit more about, only because there's ranges again, but there are some things from a media analysis that you can really detect just on its own, not so much like with the tissue analysis, we had crop specific ranges to compare to and look at. A media analysis is going to tell you a little bit more of what's happening in that root zone. So starting at the top, you know, your EC, that's going to signify the electronic conductivity in your root zone, you know, what's happening in there. You know, if it's less than 1, you're probably underfeeding. If it's above a 4, well, you're probably not following a continuous liquid feed program, which is okay, but is that where you want to be? Do you want an EC of 5 or 6 in your root zone for your plants? How hard are you pushing them? You know, that's pretty much, I just start with EC and I'm like, all right, is this a spicy media sample or is it pretty toned down? And then go from there. It's going to give you your pH as well. So that's pretty standard. You know, you want your pH to be anywhere from like a 5.5 to a 6.5, showing how your elements are going to be available. And then, you know, kind of just working your way down, understanding the solution you're putting into that media and how it should look in these results. So understanding your solution strength and then how it's looking in the media. So it just kind of goes through them, all the macros and micros. A lot of times it looks like this example, they were probably going in at around 150 parts per million nitrogen, like we normally recommend with a continuous liquid feed. And most things are coming in where you would expect them. It's pretty standard part A and part B media solution. nothing crazy. Your sodium and chloride at the bottom too, that's something I always keep an eye on. You don't want that to get high or anything plant stress. But yeah, everything's looking pretty solid on this one. Micros are in.
Caitlin, our calcium magnesium ratio 2 to 1, another thing
Yep.
that we look at. Yep.
Yep,
Want to have
exactly.
that calcium,
Yep.
2 parts calcium to 1 part magnesium. That's the other thing that we always look at on the media test and tissue.
Yep.
Yeah.
But then pretty much, and like I explained before, this is going to give you the correlation of like, how's the media looking? Is anything off with that? What is available for the plant? And do we need to make adjustments? That's what this analysis is going to tell you. And that's what myself and Brett and Lauren, we're here, the tech team, to help talk you through it if you have questions. And maybe you don't, maybe you know what you're doing, which is awesome. But the tech team is here too to help make little recommendations, tiny adjustments, adjust frequencies, and so on and so forth. So yeah.
Caitlin, on the a chat came in, so similar to the tissue,
Mhm.
are there target ranges for media sampling
So
for cannabis?
okay, so that's a good question. And that's where I didn't put a slide together on that specifically. I would say, obviously we have normal ranges listed here, but they're still
Yeah.
fairly far and wide. Your media ranges are, like I said before, it's going to be more specific to the strength of the solution that you're feeding. So if you're understanding, and I'm going to jump to this next slide, Greg, because it makes a little more sense if I can show this.
Okay.
If these are so this is the JAX 321 program. If this is the solution that you're putting in to your plants, so right here is total, this green row is your total delivered elements. As long as you have an understanding of what that is, this solution is going into your media. Your media should reflect similar ratios to what is being shown in your solution. So let's just look at calcium and magnesium for an example. So the 321 program is going to deliver 120 parts per million calcium and 81 parts per million magnesium. So if we go back to this media analysis here, we're looking at 150 parts per million calcium and 84 parts per million magnesium. So your root zone is there. Now, the numbers are going to be a little off. I'm assuming this sample was probably taken shortly after a feeding. In a perfect world, it should probably be a little lower because your data should be a little lower than your inputs on media, just because the plants should be taking them up. Like this shouldn't be perfect all the time.
Okay.
If you know what I mean. But the understanding the elements in your solution that are being delivered is going to give you a better baseline to compare your media results with, if that answers the question.
I think it comes pretty close. So it really is more about your crop and when you're feeding and when you're testing. And hopefully I think where we're going is that the grower, the customer can dial that in and understand those numbers relative, as opposed to you providing a set number of figures for cannabis.
Yeah. Yeah, no, that's exactly right. And when you look too on our bags, especially our part A labels, we have an elemental concentration chart on the label. So not, I mean, that's going to give you an idea. If you're following our recommended rates, that elemental concentration chart pretty much shows you this information here on that bag at our recommended rate. And if you want to play with it from there, you make your own assumptions, or we could help with some like more specific data. But
So some good stuff is continuing to come into the chat. So the question is, they're a JAX 321 user, and do you recommend taking media sample after feeding, or how long after feeding? And they're growing in core. And if you could answer that, Caitlin and Bill, and also just touch on we have a wide range of attendees on this webinar. And you've already referenced 321. Can you just connect the dots on the 321 concept?
Yeah, sure. That's what I'm going to do on this slide.
Yeah.
So we're just going to dive in. So the JAX 321 program, that's our most popular two-part system, technically three parts with Epsom salts. But what it is, it's our Part A 5-12-26, and that's going to cover your macros and your micros. And then the Part B is calcium nitrate, and that's where you're going to get your calcium and a little bit more nitrogen from. And then Epsom salt is additional magnesium and sulfur. If you look on this chart here, a lot of times when I'm really working on a streamlined program, we can get away with just using Part A and Part B. Specifically, when we're looking at magnesium and sulfur, you're already providing 63 parts per million mag and 84 parts per million sulfur. Your Epsom salt is only adding a little bit more to that. And at the end of the day, when you look at the ranges, so your mag range is around 60 to 100 parts per million, sulfur is around 60 to 300. You're within the range with Part A. But this is kind of our standard program across the board. You know, we have the MPK set at these rates, specifically P and K are a little bit more elevated because Part A and Part B can support all stages of plant life. We've seen a lot of great success with grows, starting with A and B from veg all the way to harvest. And it does great things. It's a packed nutrient program. And these are the numbers to prove it, I guess. It's a solid two-part system, and not everybody wants a two-part system, but at the end of the day, you're going to get that flexibility, which we're going to talk about a little bit more in the next slide. Your calcium and magnesium are covered. Again, calcium and magnesium both have a 2+ charge, so the plant can't recognize calcium and magnesium as separate elements when it's taking up nutrients. It sees it all as the same ion. So that's why, as the grower, it's really important, and as us, as the nutrient manufacturer, and when we're making these programs, that calcium is provided at this 120 parts per million, and magnesium is provided at 60 to 81 parts per million. You want it to be 2 to 1 to prevent any kind of imbalances or calcium deficiency or anything like that down the road. Because again, like the plant can't tell the two elements apart. They're just going to take them up. So you want to make sure they're being delivered in the right ratio. And then again, micros, and that's one thing working here at JAX, our micro packages are pretty awesome compared to other programs that might be out there where you might have to add a couple elements or something like that. Our blends are packed full of them, and you're going to see that all in the Part A here, is where all of those are found. But again, that can limit your flexibility. So when we're talking about flexibility, you know, there's a way it should be managed when you're using Part A and Part B. And I'm not going to lie, I've seen growers do some pretty crazy stuff, push some intense ECs. For short periods of time, I can't say yes or no. Long periods of time, I usually say a hard no of pushing super, super high ECs in terms of stressing out the plant unless you're getting close to harvest. But the flexibility can be limited. And we'll just start by looking at part A here. We don't want growers to exceed 75 parts per million nitrogen in their solution. At that point, you're going to be increasing your micros too much. You're going to get weird imbalances, either between iron and manganese or just too much boron. You're just going to see weird things. Part A, it does a pretty solid job at 50 parts per million nitrogen. And again, it's really the micros and the magnesium too. There's a lot of magnesium in Part A, and you don't want that to get too high in relation to what you're delivering your Part B at, because again, you're going to throw off that balance. I think where your true flexibility comes in this program is with Part B and how much calcium you want to deliver. 100 parts per million nitrogen is what we recommend. It's a good boost of calcium. You know, you can see in that chart, I'll say it again, 120 parts per million calcium is being delivered there. Going beyond that, we don't want to be wasteful. We want to be efficient in how we're feeding our plants, spending our money towards that feed. but it's nice because you can dial it back. Depending, it makes, for the most part, in a perfect world, 3-2-1 works with pure water sources, RO sources, pretty low EC municipal waters. But at the end of the day, I have seen less water sources that 3-2-1 doesn't work in compared to our one bag formulas. Our one bag formulas get more specific based on the water source. The flexibility in 3-2-1, we have a little bit of a wider range in terms of your water quality that you're using, unless it's like super, super, super jacked up water. You can adjust that calcium, you can lower it and compensate. Like if you have a water source that has like 60 parts per million calcium in it, we can still probably get away with 3-2-1. You might just have to dial back the part B a little bit to make up for what your water carries on its own. And again, Bill, I don't know if you wanted to talk about transpiration. I know you had some comments on it earlier.
Yes, environment's very important in calcium in nutritional speaking. Look, you could be adding a lot of calcium and your plants could be showing a calcium deficiency if your environment's wrong. A plant, well, let's back up a little bit. A calcium molecule is a fairly large molecule to move through the plant. And in order to do that, it needs to transpire. The plant does. So if you have very humid conditions, that plant really has no ability to transpire. You're not moving that calcium through the media and into the plant and out to the edge of the leaves where calcium needs to be. So it's important really to have the proper environment in order for that plant to breathe. So you move calcium through the plant. Very often, particularly in some of the ornamentals too, we get calls that I am putting calcium on, but I'm showing calcium deficiency. And really what it comes down to is an improper environment to help move calcium through the plant. So be mindful of that, really. Plants need to transpire to move nutrients throughout the plant.
Good stuff. Thank you, Bill.
Yep.
So we're wrapping up here. I think we have about 2, maybe 3 slides to go. Just some key points we want to talk on. Not so much points, but just like the buzz that we hear a lot when we're out talking to growers, and especially new operations that are just getting set up, and we're talking with like a lot of local municipal authorities in terms of like where these facilities are popping up at. Phosphorus is always like a hot button element, I guess I could call it. And we're aware of it, and we want growers to be responsible with it in terms of runoff. So making sure you're delivering what the plant needs. We have expanded our Part A offerings. I think 2 years ago, we came out with a 6-6-26 low phos. So again, this is another Part A option. I guess you could say alternative. It's another Part A option that is on the market. And all of our Part A's are uniform across the board when it comes to the micronutrient package that's being delivered. At this point, we are only adjusting the macros when we are changing these elements. So 6-6-26 is our answer to growers who need lower phosphorus inputs where their runoff is being strictly monitored, whether that's around the Chesapeake Bay area or whatever kind of regulations might be in place for where their facility is. So a lot of times we will recommend this 6-6-26 low phos in veg, and then going to our 5-12-26 during flower. I know this is specifically a cannabis talk, but also just another CEA space that this really comes in handy is leafy green and herb growers, crops that are a shorter timeline, that really don't need a lot of phosphorus because they're not really a flowering plant, but they need a little bit so they grow properly. This is where low phos really comes into play as well. And really, is too much phosphorus a good thing? Bill and I were talking about this earlier. Like, it's not bad science, but like back in the day when Bob Peters was formulating these blends, like higher phosphorus formulas were popular. You know, in that time, they were shooting for more flowers. You know, those cut flower growers wanted more blooms, more blooms, more blooms. And if you hammered them with phosphorus, they'd be blooming like crazy. However, at the end of the day, cut flowers, longer stems, longer nodes, like phosphorus is going to stretch your plant out too, which you don't necessarily want in controlled environment. You want more compact growth. You want shorter node strengths. You want to be efficient in the space that you're growing in. So that's where the slow phos kind of helps keep the plant from getting too long and leggy in the beginning in a way, but honestly 5, 12, 26 isn't that bad either. And then this photo down here is phosphorus deficiency confirmed with analysis. Again, I've seen it a lot. It's the purpling leaves sometimes between the veins here is a sign of phosphorus, but like I said, I am not making I guess assumptions based off photos anymore, because I've learned a lot in terms of looking at analysis compared to photos that I'm sent. And I would say this would be classic phosphorus, but and it was with analysis, but I just don't make assumptions shooting from the hip with pictures anymore, because plants are crazy. So
And if I could just interject here in a minute too.
Yeah.
Like you referred to, phosphorus, looking at that, like Bob Peters did, years ago as a horticulture chemist, thoughts on this have changed dramatically. Back in Bob's day, like you said, for cut flowers, it was felt that we needed a lot of phosphorus. We had to get it on there. Boy, that has changed. You talked about the internodes, about stretching out the plant, also the responsibility to the environment, and phosphorus and eutrophication into waterways and so forth. But let me point out another thing. We're also seeing that over applying phosphorus can tie up minor elements, and particularly manganese and zinc. So if you're running into issues where you're seeing deficiencies with particular miners and you're adding a lot of phosphorus, my advice would be cut back on the phosphorus and see if you can't make some of those miners more available. So a lot of things to look at with phosphorus. Now, I think the feeling in past has always been that you needed the big blooms, the big buds, and you needed to add phosphorus. And that's really what we're finding out from research. That's really not true. So.
Exactly. And that goes right into our final slide here in finishing the crop and toning it. And really the focus that's really come around on potassium and how much that makes an impact in terms of finishing the plant. And old school, like hothouse tomato growers have had this code cracked for a long time. I think, increasing that potassium at the end of the cycle just makes the fruit taste better, makes it develop more, makes the color really pop on it. Cannabis plant isn't that far from it. I mean, obviously it's not a tomato, but at the end of the day, it's a pretty aggressive plant with similar tendencies. And potassium really has become a focus, and that's why the 3-2-1 program, potassium being as high as it is, it really is a great program all the way through the end to harvest. But also the new buzz in what we've been seeing is reducing nitrogen at the end. So this 0-12-26 part A just came out this year actually, and kind of was an answer to the industry that we were getting from a lot of cannabis growers we are working with, that they wanted to reduce nitrogen at the end, make those buds harder, make those buds tighter, make those buds more dense, prevent the plant from putting so much energy into lateral growth, and by reducing that nitrogen and putting the last energy that it has into really developing and kind of hardening up those buds a bit. So that's just our little some thoughts we have on potassium and what we're seeing and how we're trying to answer those needs in the industry. And then figured we'll just recap. Bill, did you want to do the recap here?
Yeah, thank you, Caitlin. Yes, great
go
job,
for it.
by the way. Handled that wonderfully. Thank you. We just want to point out here that, again, getting back to the histories of the Peters family, we sell more than just a bag of fertilizer. We're not just selling you a bag of fertilizer. What we really want to do is work with the growers and supply you with the technical support that goes into growing a crop and picking out the right fertilizer formulations for you based on your water and so forth. So we're here to help, not just to sell you a bag of fertilizer. Again, in-house testing, as far as troubleshooting in real time, consistency is the key, everyone. One of the things that you may just see between in-house testing and lab testing is you might see some differences in the numbers, but what you're really looking for in in-house testing is, what are the trends? So things like pH can be a little different and your EC readings can be a little different from the laboratory. But what you're looking for is try to be consistent. Do your pH readings in the same environment if you can. Temperature, for example, can affect pH. So as long as you're seeing consistency and trends and you start to see something go wrong, you could back that up with the lab. The numbers might be a little different, but you just want to look at the overall picture and see where you want to go with that. Um, Again, that's what I just ran into the next point here, the big picture, using our lab, using your in-house testing, and also understanding your inputs. What are your targets? I think that sometimes we want to maybe decide what you want to do with these cannabis is decide what targets do you want to hit with calcium, what targets do you want to hit with magnesium, and try and develop your program that way. So thanks for your time, everyone.
Bill, Caitlin, really great job. We've got a number of questions here that have come in that I want to make sure we get addressed right now.
Okay.
So the first one is it goes back to a two-part question, and it's when is the best time to take a media sample? Someone that's using core, just timing wise.
Okay. So this is
Relative to feeding.
Yeah.
I'm guessing that's the question.
Yeah, so we don't want it right after you feed. You don't want when your media is like super, super saturated with all that fresh solution, but we also don't want it once your media is starting to dry out. We want it like kind of in the middle. And the timing, there's no time to put on it. It's a feel of it. I would say, Bill, I don't know if you would disagree with that, but it's no different than taking poinsettia or any other crop.
Right. It's really no different. Yeah. You don't want to do it directly right after you do a excuse me, do a feeding. I'll put within a day or two, I think, like Caitlin says, you don't want the plant to dry down either because you won't get an, representative sample that way. I hate to do that, but I think you really want to, I think moisture content has a lot to do with it. And I think really you don't want to do it right after a feeding, but you don't want to wait till that plant dries out. So
yeah, and I guess the best time I would say would be shortly before you would be putting another solution application. As long as you're not like as long as you're not drying back your plants. You just want that media to be evenly moist, not fully saturated, but not dried out.
Right.
So sorry, I don't have an exact timeline. I don't know, whenever I take it's just a feel. You look at it and touch it. I don't know.
Right.
No, I think that makes sense. I think that makes really good sense.
Yeah.
We have one of our California customers has asked here, and I think you touched on this, Caitlin. What are your thoughts about flexibility with regards to reducing feed of different parts as opposed to boosting feed?
That's a good question. I mean, it's all about how you manage it, and it depends on what stage of the crop cycle you're in. I mean, my rule of thumb is feeding on a continuous liquid feed. So it's a low rate. And when I say a continuous liquid feed, it's a low rate of fertilizer with every watering. And we gauge that rate pretty much the lowest you can go without causing deficiency in a way. So honestly, I don't know that I've worked with a lot of growers that want to run a lower reduced feed all the time than a continuous liquid. If you're doing that, you're going to stress the plant out. You're going to see underfeeding in general. Kind of that one photo I had earlier. It's just your plants just aren't going to look as vibrant and strong. But the only experience I've had is like flushing, but that's like at the end of the crop, where you're like totally depleting everything. So I'm not sure. I mean, I'd be glad if they want to reach out to me. I mean, I'd be glad to discuss or get Brett looped in on it. He's got a bunch more. He's our cannabis guy. So he's got a bunch more experience specifically with that than I would.
I think that's a great idea.
Yeah.
Another one that came in here is, what's the effect of potassium silicate added into municipal water before dosing with Jack's 321? Will it affect any other nutrients other than potassium and silicon?
Not, well, it depends how much potassium is being delivered, but when it comes to adding a product like that to a reservoir, we always recommend adding it first and then adding our nutrients second in final solution in terms of like not having any weird precipitates happening.
Okay.
Yeah, I get concerned about silicates sometimes because they're not
Yeah.
very soluble. There's been some debate on that, and I think that's something we want to be careful of. Yeah, I'd be very leery of adding something like a potassium silicate to the 3-2-1 program because I think we're already at the levels where we want to be, and we don't want to really go excessively with potassium or any nutrients. So I'd rather see if somebody wanted to use that, apply it by itself, and instead of into the actual Jack's nutrient program.
Great. So that answered the next question right there, Bill. Was does potassium silicate have a place in your program? So thank you for that. That wraps up the questions in the chat. Let me just take one more look to see if anything new has come in. I think we're in a pretty good spot.
So Greg, there's a few questions in the question and answer section, the Q&A.
Great, thanks. If you can read those off, Rebecca.
Sure. So the first one is, what are Jack's thoughts on flushing the media to keep EC within parameters and flushing at the end leading up to harvest?
Ooh.
Well, I know
But
Brett's feeling on this. You could cut back on fertilizer, but you have to remember, a plant needs energy. It needs nutrients, even when it's in the final stages of bud formation and flower. And I just don't believe you need to starve a plant at that point. I still think you need to be feeding the plant. And frankly, my feeling on flushing, it's not needed. Yeah. I would keep the fertilizer. You could cut back on fertilizer at the end. I agree with that. I know we talked about cutting back on N. And as Caitlin pointed out, that's been around with tomato growers and also for cannabis growers. You don't want that plant vegging. You really want to concentrate on the buds, but I do believe you need to have some nutrients in there because of the amount of energy that plant is doing and producing and forming that bud. So it's got to have some food to perform, just like you and I. That's me.
no,
Thanks,
Bill,
Bill.
I think that's good. I like seeing a consistent EC in the root zone, but that's also my experience is more ornamental crops as well. So that's just like what I'm used to seeing with plants in terms of manipulating EC. You can do some crazy stuff, but I like a continuous liquid feed all the way through because you're not going to hit any kind of weird deficiencies.
I mean, if they want to flush because it might be a flavor issue, I guess, is sometimes what I think the concern is, or having a chemical issue. I mean, honestly, I don't see it. But if you feel more comfortable with it, flush, but I just don't think it's needed.
There's not a lot of data out there to show either way.
True.
So the Jack standpoint is always kind of neutral on it. As a grower, that's where you can play. But we haven't seen great data on to flush or not to flush. I mean, I think we even have a bulletin where that's one of the topics. And there's still, we don't have a solid answer on it. We work with growers who flush and have great results. We work with growers who don't flush and have great results. So
let's really leave it at grower preference. I think that's
exactly.
good. Yeah.
Great, thanks.
Awesome.
You had another one, Rebecca?
Yeah, there's one more. So it says, you mentioned a good environment. It helps increase calcium uptake, other nutrients as well. Do you mean having a proper VPD? Is 10 points difference between temp and humidity good? Kind of a little larger question as well.
Yeah, VPD. I guess really what we're just focusing on is making sure there's sufficient airflow. Our focus of expertise is in nutrition. So when it comes to more of the details of different set points for VPD and stuff, I don't know exactly. Bill, I'm not sure if you have any thoughts on that.
Yeah, as far as set points on that, no, I don't. I mean, I think that would be something that Brett would be able to help us out on here, unfortunately. I just think that, creating the right environment for nutrient uptake, is my point, is it really needs to transpire.
Mhm.
And, as far as what settings those need to be in a greenhouse, I think that's getting a little more crop specific, and that's where Brett would help out. So let us ask Brett and get back to you. Whoever the question or where it might be coming from, just give us the information and we'll get back to you.
We can do that.
Yeah.
Thanks.
Thanks.
Rebecca,
Thanks
does
for
that clear up the questions in the Q&A?
Yes, it does.
Great. I'm going to,
I stopped sharing.
if you could, that would be great. I'm going to do a commercial super fast.
Okay.
Great.
Yeah. Let's see here. So I want to thank everybody for attending. If you already know about Griffin, that's great. If you don't, our CEA division, we're all about 15 warehouses servicing a nationwide footprint. We are independently owned. We take great pride in providing reliable service, not only through our sales team, but also through our technical team. We are clearly focused on collaborative success, and that's the reason we have J.R. Peters on today. Contact us at the information there, the phone number, through our website. Really appreciate everyone's attendance. Hopefully we all learned something. I know I did. Caitlin, Bill, thank you very much.
Yes, you're very
Thank you,
welcome,
Chris.
Greg. This was a great opportunity, and we appreciate everything Griffin does for us and Jack's growers across the board. So thanks
Right.
for letting us be a part of this. It was good,
Yes, we
good
are.
hours spent. So
Yeah.
Thanks. Have a
Thank
great
you.
rest of your day.
Yeah. Bye-bye.
Yep. Bye-bye.
Greg, I can't get out of